now I'll be presenting the problem. Let's scroll. So first, I'll be talking about the problem statement. So gently place a piece of tracing paper on the surface of water. It rapidly curls into a scroll, then slowly uncurls. Explain and investigate this phenomenon. So our main focus will be investigating the reasoning behind the curling and uncurling of the tracing paper. And we will be talking about the parameters that may affect the speed of the curling. So this is our outline of my presentation. And from the observation, I'll be talking about the phenomena observed and the analysis of the curling motion. So from the observation, first we can see the scroll of the tracing paper is dry. But when the tip of the scroll gets wet, the scroll starts to curl towards the middle. And my explanation is that this may be caused by the difference in expansion, so the bottom layer will curl upwards, which I'll be further elaborating from the future presentation. And that is our video. And secondly, then we can see that when the scroll is curled up, it starts to sink into the water, and then it starts to uncurl under the water slowly. And our reasoning behind that is we think that as the top layer starts to expand, the whole piece of paper will start to uncurl back to its normal expanded state. So our first theory, I'll be talking about the correlation between the bimetallic strip and tracing paper. So first, I want to talk about the bimetallic strip. So it's talking about when a bimetallic strip is featured with heat, the strip will start to bend in a specific direction due to the difference in expansion of the two metals. Which, from the picture, we can see that because the copper actually expands when it's featured with the temperature change, it expands more than the steel. So we can see that when it's featured with heat, it will start bending upward because the copper expanded more. But how does it correlate to the tracing paper? Well, we think that as for the tracing paper, the differential expansion is due to the different water potential inside of the paper tissues. So we think that so I'll be talking about how the water potential will affect this phenomenon. And next, I'll be talking about this theory about the bimetallic strip. So this theory describes the bending of the thick metal beams, considering the shear deformation and the bending effect featured when there's heat within. And the curvature with time graph should show a great increase at the start and slowly decrease in the end, which will fit what we observed. But now I'm going to be talking about our assumption is that the fiber of the tracing paper, of course, we acknowledge it as many layers of this kind of metal strips, or you can see of tracing paper. So which means that there is not only two layers. We think there's more than two layers in this, or infinite amount of layers. But we think that using two layers will be much more easier to be explained. And we will. So further in this kind of my presentation, I'll be talking more about how. I'll be assuming that there's only two layers, which the top layer will be the dry layer, and the bottom layer, which will have contact with the water surface, will be the wet layer. So now I'll be talking about the moving of the paper curling. So first, for the paper to curve, the bending force caused by the water has to overcome the capillary force, which is the resisting force that I think is featured in this motion. And once it's lifting, the curling can continue when the edges is straightened out, when they're straightening out the edges, there will be another potential force that they will have to overcome, which I will talk in the future. And once it overcomes the potential energy, it will continue this motion over and over again, so it will curl up until it's to the end. So now I'll be talking about the force analysis, which I think there are two main forces that are derived in this paper curling. Which the first force is the driving force, which is the curling force caused by the differential expansion of the fibers, and the capillary force, which is mainly affected by the cohesion and the surface tension of the liquid you're using. So we think that these two forces are the competing forces that will decide whether the tracing paper will curl or not. And then I'll be talking about the edge effects, which is mainly mentioning that the paper, in order for the paper to lift off of the water surface, it will have to straighten out the edges. Which, if the edge is shorter, then we think it is very hard. It will be harder for it to flatten, because the edge, when it's shorter, is more stiff. So it means flattening out would require more potential energy, which will lead to a slower speed in the curling. But when the stiff side is over a certain length, it will curl a lot more easier, and so the speed will be faster. So then I'll be talking about how the edge effect will have an effect on our curling speed. So from the equation we derive from the right side, which is from the equation we can see that when the edges want to straighten out, it will obtain a force. It will obtain energy called the one on the left, on the left of the equation, which the B is the bending stiffness of the tracing paper, and the K0 is the curvature of the tracing paper at that moment, and the LS, which I'll be using further on, which will be the stiff side of the tracing paper, and I will then talk about what stiff side means in my next slide. And I think that it will have a correlation to after it curls, it will have a speed to curl up. So I derive the energy it obtained. It will turn into a form of kinetic energy, which then we can know that the velocity will have a square root relationship with our stiff side length. So this is mainly talking about of water when it's actually entering a small tube or something like that. It will have the diffusion of the liquid, which will be featured. The diffusion of the liquid will be different. So this is mainly talking about that. But the main part I'm going to talk about is that because we use the same piece of tracing paper, so the value of m and n will be the same. So we think from this model, we will be seeing that the curvature, which is k, will have inversely proportional to the thickness of the tracing paper. So we think that the factor that will affect the velocity of the curling is the thickness and the length of the stiff side of the paper. And we think that the factor that will affect the radius is the thickness and the capillary force. And our mentioning here is to talk about when paper manufacturers that are manufacturing the paper. The paper fibers aren't aligned in random order. They will align in one almost to parallel. So that means one side of the paper will be stiffer than the other side, which I will do a video from this. So from this video, we can see that I create a square piece of tracing paper, and once the tracing paper starts to curl, because both sides are the same, so we know that the edge effects are the same, and we see that only one side will curl up. It's because that the side, which is the left and right, the bottom side, is much more flexible because of due to the manufacturing process, which will mean that which side we use will affect how this will curl. So then I'll be talking about the method of how we're going to experiment this. We will use a ruler inside of the water, and then we will measure how much it has curled from its original state, and then we will divide it by the time it elapsed. And this is our experiment. And from the experiment, I will use a tweezer to snap the tracing paper, and I will immerse it in water. So one side cannot curl. So I will only estimate the curling of the other side. So these are control variable, and our independent variable will be the length of the stiff side and the flexible side. And this is our data analysis. So from this graph, that we can see that at the start from 1 to 3.5, there is a steady upwards, and then it will start to get slower. Like the growing will slow down as it features when it goes to 5. So according to our theoretical model, I square the value of the y of the velocity. So when it matches linear, like that equation, it will have when it's linear. That means the fitting will mean that the y will equal to the square root of x. And this is another fitting of the original data, and which also proves that our theoretical model is somehow correct. And the radius over time, we see that it didn't affect because we immersed it in the same we immersed it in the same pool of water. So the capillary force will be the same, and it wouldn't have much effect on the radius. So, and the discussion is that from this we didn't discuss the thickness of the tracing paper because in the start we tried to fold the paper and double the thickness, but the substance we used to thicken will block the water diffusion, so the top layer will not be wet, and the method of tracing paper will change too, which we think that it will affect. Thus we didn't change the thickness of the piece of paper. So the conclusion, we think that the radius will stay the same and the speed will increase as the length of stage time increases. And from the theoretical model, we think it is almost a square root relationship. And that's the end of my presentation.
Okay, the first question I want to ask you, did you make sure that the tracing paper different position will touch the water surface at the same time?
To answer your question, I hold the paper like this is the tweezer and this is the paper, and I will lower it down on the.
So it will touch the water surface at the same time?
Yes, it will be almost the same time.
Okay, and did you control the humidity of your experimental environment?
We use
Yes or no?
Yes.
Yes, okay, thank you. And next, we know that the curling velocity is faster than the uncurling velocity, right? And did you think what is the main factor to that tracing paper will have different velocity of curling and uncurling?
I think the main factor is the diffusion speed of the water.
Diffusion speed of the water.
Yes, how fast the water will go through the tracing paper.
Okay, and next, did you think when the tracing paper stops curling and the tracing paper will become move or rotating on the surface of the water?
Can you say like what?
If your tracing paper starts to curling and you think that the tracing paper it will rotating on the water surface or move on the water surface?
Because I used a tweeter to control one side, so I didn't see any rotation or movement.
Okay, and next I want to ask, assume that tracing paper has many layers, and did you think that the water penetration, the direction, it will always from the low layer to high layer, or it will have a horizontal direction of the penetration of the water?
I think if you place it on the water surface at the same time, it will mainly go up.
And then go up. Okay. And that's all of my questions. Thank you. force analysis about the surface tension and only consider the ideal situation and didn't calculate the Young's modulus of the tracing paper. And for the experimental part, they changed the length of the stiff side. And the pros, they control the position of the tracing paper which is on the water surface. And the cons, they use hand to release the tracing paper, which will cause the tracing paper center and the edge will not attach the water surface at the same time. And that for the data analysis part, they compare the parameters with the velocity of curling. We think the way that get the velocity of curling is nice. And for the cons, the lack of the theoretical line and didn't explain the difference between the theory and the experiment. And here is the discussion points. And I want to discuss about the tangential bimetallic thermostat and assume the tracing paper have more than 2 layers. And did you think that the water penetrate direction will always from the low layer to the high layer, or it will have the horizontal direction in one layer if the tracing paper is curling? And for the experiment and setup part, I want to discuss about the did you think when the tracing paper starts curling, the tracing paper will move or rotate on the water surface or not, and if it will move or rotating, what is the reason to cause that? And do you think that the tracing paper curling direction will be affected by what factor, like the fiber direction or what? And the data analysis part, I want to ask the curvature and parameters relationship and the difference between the curling and uncurling velocity. And now I want to invite the reporters to discuss. Okay, and did you think that the tracing paper curling direction will affect by what factor?
I think that how the fibers are aligned will affect the curling.
You mean the fiber direction or?
Yes.
Okay. And the size of the paper or the ratio of the long side length is that affect the tracing paper curling direction, or it will just affect by the fiber direction?
I think that will affect, but that is not the main reason which side will curl more.
Okay. And next, did you think the tracing paper will always float on the water surface, or it will drop down to the
I think from the observation, very start observation, I said that once the water starts to penetrate through the whole tracing paper, the tracing paper will start to sink inside of the water,
Yes.
and then it will uncurl.
I mean that if the tracing paper, it will always float on the water surface, or it will drop down to the bottom of the container.
I think at the start, like when the water, like when it's curling, it will always be on the water. But once it finishes curling, like when it's together, they can't curl anymore. It will start to sink into the water.
Okay. And next, please turn to page 10. In here, we want to talk about the tracing paper that it will penetrate the water because of the capillary force or.
I think that it is mainly the diffusion of. We think that the capillary force is how this will stop. Right, the water going into the tracing paper is firstly capillary force, but once capillary force, after the capillary force, it got into the. Oh, I think I used the for might be clear.
Okay.
I think like if this is a thick layer of fluid, I think the water surface. I think capillary force will first that the water molecule gets into the tracing paper. So I think this is capillary force. But once the water is inside of the paper, then once if the molecule wants to move, but wants to maneuver inside of this piece of paper, then it will use molecular diffusion.
Okay, and do you think that if the temperature of the water it will affect this result?
Yes, I think it will affect the capillary force and it will affect the diffusion.
I think it will just affect the diffusion because the diffusion coefficient will relate to the temperature of the water or the environment. So I think could you control the temperature in your experiments?
Yes, we use the same the temperature of the water
same time, and it will always go like this direction.
I think what I mean by saying it mainly got is because like if it all touch at the same time, then maybe like this part will all have water. So I think that like even if the water goes like horizontally to this side, it wouldn't affect the water potential of the bottom layer of this too much. So I think what it mainly the diffusion affects is like whether it will go up onto the at the next layer.
And could you try to use this theory to explain why the curling velocity and uncurling velocity will become different?
You say that because as from like this will start to expand, but because of different layers, so the time because like it is different like because the water potential, right? So if this layer wants to go this layer, is differently difficult to go to next. So for example, like if the water wants to go from the water surface to maybe this level, it will be a lot easier than if the water wants to go to the top. So if the bottom layer starts expanding first, it will be faster and once it goes to the top.
No, but I think that is because if the water is penetrating in the tracing paper, and because if that is in the tracing paper will start curling, right? So I think the area which the tracing paper will connect to the water surface will decrease. So I think the penetrating velocity will also decrease. I think that is because the tracing paper is curling. So the area which is touching the surface of the water is decreased. So the penetrating velocity also decreases. I think that is because you said that this part is faster than this part. Did you agree?
Yes, I think this might be this is a reason factor.
Okay, and if you calculate the Young's modulus or another Lodman expansion coefficient of your experiment.
Thank you. I didn't hear you.
Okay, because you said that if this is the fiber direction of the tracing paper, and the direction of the tracing paper curling will like this, or yes, and I agree with you. And because you said that it will curling like this, and I think that is because this part and this part, the expansion amount is not the same, so it was just curling in the one direction.
Yeah, because I said that because of the fiber, so this side will be stiffer, and the bending coefficient will be larger. So it will be harder for this side to bend because it will cost more energy to overcome the force of lifting this piece of paper.
So you think if the tracing paper put on the surface, water surface, and this part, the expansion amount will become more or smaller?
I think it's smaller.
It's smaller.
Yes, because it's more stiff. The model is larger.
Okay, I think if that is curling in this direction. Oh yes, I think I also think that is this part it will. No, I think if that it will curling like this direction. This part expansion amount might be more bigger.
But I still think that because of the expansion is larger on this end, like for example, maybe I'm talking like because I think that if it expands, so this side will curl. It becomes the bottom layer expands this way more, so it will curl up.
Yes, it will expand this way more.
Yeah, so I mean
this part expansion amount will become more large.
Oh, yeah.
Okay, and you said that the fiber direction will affect the result, right? And did you found in your experiment you found that if you put the tracing paper on the water surface and it will form three kinds of the shape of the tracing paper, like this three kind of the tracing paper, or it will just form this curve, or
I see this and this.
this and this.
Yes.
And why do you think it will not like this?
Because once it starts to curve, like and if it's like this, okay, the gravitational force will pull it back down, and then if it cannot part will start to expand, and then this will go back to flat. And
So, although this part, if that the tracing paper is like this is longer, much longer than this side of it, and if the current direction is like this, and do you think that it will not happen?
yes, I think like in the middle will be a bit like
Okay.
not yeah.
And because you didn't mention the surface tension in your presentation, and I want to talk to you, and because if you the tracing paper will curling, right? So if this part, which is before it is touch the water surface, and when curling, it will touch the tracing paper. So I think that the tracing paper, this part will have a surface tension so that the tracing paper uncurling velocity becomes slower. And did you agree before it will have another?
I think that if we are talking about like surface tension, I think that this leaking will cause this this will have a loss of energy. So I think the curling speed might be affected by this one. But I didn't consider it in my theory.
Okay, and because your presentation will have a model of the curvature, right?
Yes.
And you calculate the exact curvature data of your experiment.
I think I only use it to derive the function of like the curvature will be inversely proportional to this.
So you didn't get the exact number in your experiment.
Yes, I just borrowed it to prove my.
So and could you try to say that if you want to get the curvature of it, you will how to get it?
Do you want to like? So do you want to have like how do I try to get this?
Yes.
I think that if I were to try to do this experiment, I think I will use this type of curvature pattern because this it will not fall into a whole circle, so that I think the curvature will only be like this. So it's easier to see the like right track.
But you said that it will not form a straight line.
Because I didn't do that type of experiment.
Okay. Okay. So if you want to calculate the curvature, which is the straight line.
Yes.
But I think this also can calculate the curvature because if you get.
I think this will be a lot more simple because for this, like the.
You just need to got this part R and get the R 1 over R, then you can got the curvature.
But I think that the curve is not always like the whole circle, right? Of course, like because of the water surface tension, so it will start to form a circle. But I think in the start, this cannot be counted as a whole circle. So I think using this will be a lot more easier.
Okay, for the summarize from the theoretical part, we discussed about the penetration of the tracing paper that is because of the Morelli force or the diffusion, and the reported thing that is the first of it is the Morelli force, and then is the diffusion. And I think that is the diffusion, and if they think that is the diffusion, they need to consider the temperature of the experiment. And we discussed about the bimetallic equation and to explain why the curling and uncurling velocity will become different. And I think that is because the tracing paper touching surface on the water it becomes smaller, so the penetration of the water will become slower. Okay, thank you.
Okay, and welcome for the program. And I heard that we discussed the surface tension in the vector class.
Yes.
So surface tension is mainly caused by the type of liquids. So if you change water into like alcohol, what is the effect?
It is ethanol.
Alcohol.
Alcohol. Oh, alcohol.
Would is
Effective.
faster or
I think because alcohol has because of alcohol having like fewer surface tension, I think it will curve a lot faster because the energy loss when it's curved into the cell it will be less.
Yeah, I also think if we change the type of the fluid, like the bubble water or the alcohol, because they will change the surface tension, so I think it will also affect the experimental result.
And can you show your experiment video?
Video.
Already.
Okay.
Okay. And in this video, you let it drop in the water.
Yes.
And it occurs. But
Yes.
before it drop in the water, you take it out. So would it occur or not?
Did I take it out of water
Yes.
before it occurs?
Yes.
Will it occur? I think if I take it out of water, it will uncurl. It will still uncurl, but it will be slower.
And is there another video? Right?
Another video. Oh, is it the square video? Okay.
As you can see, there are air bubble in between the paper and
Yes,
the water. So do you think it is vital for the result or not?
I think it will affect the result, but this is just a demonstration video to show the stiff and flexible side. So the air bubble, I didn't actually control that.
Okay. And a question for both. You use your hand to push it to put it in the water. So do you think the humidity on your hand, like the sweat,
Oh, you need sweat. Okay.
will affect the result or not?
I think it might have a minimal effect on the result, but I think the overall curling speed and the whole thing will not be affected.
I think definitely yes, because our humidity of our hands or the humidity of the environment all will affect the experimental result.
Okay, thanks. And that's all. Okay, so I'm a reviewer from the club, and today's topic is question. So the main focus of us is curling and concluding for the tracing paper and the parameter. So the theory is that the reporter is the pressure of the water will cause the rolling phenomenon, and overcoming help free force and the velocity will be constant. And if the tracing paper curls, it will gain energy, and energy will be transferred. The speed of the retraction depends on the diffusion of water. So the summary of the classification. First, the experiment changing the LS to find the maximum velocity, and changing LS to find whether it will affect the radius, and the result showed infinity. Second, the result, the speed increase as LS is changing, and the curvature remains the same while the paper is further. So for reporters that have a clear explanation about the topic, but they consider your models and some force analyze and experimental process, and that's for association between the theory and practice. And for often, the process asks questions precisely and detail, and putting as no cause. So the first discussion, the often question is that what factor will affect the tracing paper? And the reporter's answer is the fiber conversion. The second discussion, the often question, will the paper be on the water the whole time? And reporters say it depends on the time. And the third discussion, the often question is, will the temperature of the liquid affect the rolling phenomenon? And reporters say no, it doesn't matter, but it will affect due to the diffusion. Then the fourth discussion, they ask the diffusion of water, and they respond with their theory. And our question, changing the liquid into alcohol, and both answers it will be faster, but we think the alcohol has small surface tension, so it may quickly rise to the top layer, so that may affect the result. And the second question, using hand to put the paper on the surface of the water will affect the result. And the reporter say no, well, the one say yes. Okay, thanks.
So I will be making the concluding remarks. So firstly, we think that the side of the paper, which is the long side, is not the main reason. We think that whether like it is long or short, we think that the start of the curling, like which side it will start to curl, will be mainly affected by how the fiber is orientated, which we think the long side is not as a majority of factor. And second, the tracing paper will flow first, but it will sink after the water has gone into the tracing paper. And thirdly, we think that the temperature will influence the diffusion rate, but we use the same room temperature. And fourth, we think that the capillary force is the force that will start the motion, but the molecular diffusion is the one that will affect the whole curling. And fifth, we think that alcohol has fewer surface tension, so we think it will curl much faster at the start. And sixth, if we take out the paper before uncurling, it will still uncurl, but it will uncurl slower. And seven, that we think the bubble will affect the result, but we controlled it inside of our experiments. And next, we think we use Peter to avoid the slip, but we think it will still have minimal effect on the results. And lastly, we believe that we want to ensure whether it's capillary force or molecular diffusion that affects the whole curling, we use bubble water to experiment because capillary force is affected by the surface tension, but molecular diffusion is not affected by the surface tension. So we think that changing the surface tension of our liquid will help us ensure which force is the main force that causes the curling. And that's the end of our presentation. Thank you.
Question from Louis.
The report said the current direction is perpendicular adhere to the fiber direction. The fiber align this way, the
Yes.
current direction
Yes.
is perpendicular. Can you approve that? Can you prove that?
Prove that. I think that if I want to prove it, because fiber fibers can be observed through a
How to
microscope.
prove that?
Proof,
Yeah, how do you prove that?
like through a theory, or is it like
No,
observation?
experimentally.
Experimental. If I will try to do it, then I will first see, like with a microscope, to see the fiber orientation, and then once I make sure which side is the orientation. For example, if I look, it looks like this on the paper, in the microscope, then I will take a piece of paper and place it in the water to see if it is same as what I see.
How about the reviewer? What do you think? How can when you want to prove that the current direction is perpendicular to the fiber direction? How will you prove it?
It cut it in several pieces and put it horizontally or vertically and
Well, when you do the experiment, how do you prove that experiment?
experiment.
Yeah, and how to what kind of experiment you will do to prove that?
So we cut it in different shapes and put it to water,
Different shapes.
different shapes. And if we curl in the same direction, I think it can prove it.
What about you?
I also think that we can check the fiber direction under the microscope, and if the direction of the curling that is vertical to the
If you don't have microscope, what will you do?
if we don't I think we can cut a large paper, and then the cutting direction maybe can, like, this is horizontal and this is vertical, and then this one is like this.
I have a question for reporter. So, how do we measure the velocity?
The velocity. I mainly measure the velocity by by the length. The length that it has curved divided by the time it has elapsed.
How do you define, what's the tracking point that you are looking at?
My tracking point is the edge. Like, for example, like it is at the start, maybe it's like this flat. So I measure this distance, and then when it starts to curl, I look at because I will look at the water surface, so I will look at this point. Because all of this is curled up, so I count this point and subtract.
But it's rotated.
Yes, it's rotated.
So you are measuring the angular velocity or the velocity.
Because I measured the length, I didn't measure the angle. Because I didn't measure.
Yes, but you're tracking this.
Yes. Yes, I know I'm tracking. I know I'm tracking, like I think it is velocity than angular velocity, because angular velocity is the angle it has gone divided by the time. So maybe if I have like a curvature here, and I see like the angle is like this, so it goes from 0 degree to maybe like this many degrees, like how much it has rotated, I think I can calculate the angular velocity. But because today I measured the length from the original state to this part, because this is the length, not the angle, so I don't think we could use angular velocity to define it. So I use normal velocity. Thank you.
Thank you. I think quite a simple question. I think here you guys spend a lot of time to discuss the orientation of the fiber in the paper. But the report also mentioned age effect is also quite important. So which one is more important of these two effects?
I think that the orientation is mainly like it will affect like the stiffness of the tracing paper, but because I haven't done an experiment mainly on like different orientation of tracing paper, so I'm not sure.
decide the direction of the paper. Right.
Because they said that if the tracing paper will curling, the direction of it will always like vertical to the fiber direction. But I think that maybe we'll have to have a limit and they can do the experiment without the limit of it. Because I think if this part is longer, then I think that will hardly trace the curve.
No, you're not sure? Okay. So that's okay. Let's have the score of the reporter. Okay. 76677. And the score for the opponent 76677. The score for the reviewer 55556. Okay. That's all. Any comments, general comments on the jury? Okay, no. Let's thank the juries and all the teams in this afternoon section.